of physical chemistry. It deals with what the conversion of chemical energy into electrical energy and electrical energy into chemical energy, electrical energy into chemical energy. So see, so the topic deals with the conversions of one energy to another energy and vice versa. Okay, and to convert these energies, it require a device. It require a device. Okay, the device is known as cell. Okay, so to convert the chemical energy into electrical energy or electrical energy into chemical energy, that process requires a device. Okay, so that device is known as cell. That device is known as cell. So what is a cell? Cell is a device which converts the chemical energy into electrical energy and electrical energy into chemical energy. So based on that, the cells are classified into two types. The cells are classified into two types. What are they? So one is the electrochemical cell. One is electrochemical cell, and second one is electrolytic cell. Electrolytic cell. So based on the energy conversion, the cells are classified into two types. They are, one is electrochemical cell and second one is the electrolytic cell. So what is an electrochemical cell? Okay, what is an electrochemical cell? See, electrochemical cell is a device. Electrochemical cell is a device which converts chemical energy into electrical energy. Okay, so electrochemical cell is a device. It is a device which converts chemical energy into electrical energy. Means these cells convert the chemical energy into electricity. These cells generate the current from the chemical energy. These cells generate the current by performing the chemical reactions. Okay, what type of chemical reactions are generally take place in the cell? Means redox reactions. By performing the redox reactions, the chemical energy is converted into electrical energy. By performing the redox reactions, these types of cells generate the current. So these cells are also called galvanic cells. These are also called galvanic cells, and simply we can also called battery. Okay, battery and kuda anachu. Okay, so what are the cells? These are also called galvanic cells and battery. So what are the batteries? Batteries are the portable devices which are the sources for the electricity. Okay, portable devices means we can carry anywhere. So that is the meaning of portable devices. So which convert the chemical energy into electrical energy, or which are the sources of the current. And so that we are called battery. Okay, battery. Right. So then examples. What are the examples of? Sorry. What are the examples of? Okay. Hmm? No, clear all. Okay. Right. So then examples of the electrochemical cells. Examples of the okay. So examples of electrochemical cells. What are the examples of electrochemical cells? So you know so many batteries. So but you don't know the what is the chemical composition of the batteries. Okay. you are using batteries, but you don't know the composition. Okay, you are using the batteries in the mobiles. So what are they? Just you know that is the battery, but you don't know the chemical composition of that battery. You don't know the exact chemical name of that battery, isn't it? Okay, so that is, so in our battery we can use this battery, that is lithium ion battery. So lithium ion battery is the battery which is used in our mobiles. Okay, and then lead acid storage cell, lead acid lead acid storage cell. So this is also one of the battery and which is used in the automobiles. Okay, which is used in automobiles. Okay, like that, so many cells are there. Nickel cadmium cell, nickel cadmium cells. Okay, and these are what electrochemical cells. Okay, what are these? Electrochemical cells are the devices which convert the chemical energy into electrical energy, which converts chemical energy into electrical energy. So what type of chemical reactions are takes place in the cells? Redox reactions. What are redox reactions? Oxidation and reduction reaction. Okay, oxidation and reduction reactions are takes place at respective electrodes, and by the redox reactions, so that a cell generate the current. Okay, so in upcoming topics, how can that cell generate the current? Another, let's see. Okay, so this is what electrochemical cell. And second one is, what is the second one is? Electrolytic cell. Okay, electrolytic cell. So in our cell bus, we have only electrochemical cells, but not electrolytic cells. Okay, but we have to know what is that. Okay, so what is electrolytic cell? So electrolytic cell is the device which converts this opposite to the electrochemical cell. So it is the device, it is the device which converts electrical energy into chemical energy, electrical energy into chemical energy. So these types of cells are called electrolytic cells. So what happened in the cell? By using current in that cell, the chemical reactions are takes place. By using current, that is electricity, and that electricity is used to perform the chemical reactions in the cell. Okay, so those types of cells are called electrolytic cells. Okay, electrolytic cells. Example of the electrolytic cell is electrolysis. Electrolysis is the process, okay, in which the electrical energy, when we supplying current, what happened? The respective ions, the ions are migrated towards the respective electrodes. That is what electrolysis. So you studied in the lower standard. What is electrolysis? Electrolysis is the process of migration of ions towards respective electrode by applying some current. That current is used to perform the uh, chemical reactions in that cell. That is known as electrolysis. Okay, so this is about the electrolytic cell. Okay, and so now, so in our cell bus, we have only the electrochemical cells. We have only the electrochemical cells. Total chapter around the electrochemical cells only. Okay, మొత్తం చాప్టర్ కూడా electrochemical cells ఏ ఉంటాయి. First, what is the cell structure? Okay, what are the how can you construct a cell? Okay, so let's see. So this is so next to electrochemical cell. So electrochemical cell is also known as galvanic cell, and the best example. So here we explain electrochemical cell by taking one example. By taking one example, we can explain the electrochemical cell, how the current is generated. Anadi మనం చూద్దాం. See, so best example for the electrochemical cell is Daniell cell. What is that? Daniell cell. So how the Daniell cell? So generally, so before going to Daniell cell, so what is the cell structure? Every cell, it may be electrochemical cell or electrolytic cell. Every cell consists of two electrodes. Every cell consists of two electrodes. Okay, which are dipped in an electrolytic solution. An electrolytic solution, and they are externally connected through a battery, and internally are connected by the salt bridge. That is the cell structure. What is the cell structure? Every cell consists of here every cell consists of two electrodes. So one is anode and another one is the cathode. Okay, and these two electrodes are dipped in an electrolytic solution. An electrolytic solution like this. Okay, this is the one electrode and this is the another electrode, suppose. Okay, so here this is one electrode and this is the second electrode. Okay, and these two electrodes are externally connected through a battery, and internally they are connected by a salt bridge like this. Okay, so every cell like this. Every cell consists of two electrodes. One is anode and second one is the cathode. Left side electrode is anode and right side electrode is cathode. Okay, and these two electrodes are externally connected by a battery, and internally they are connected by a salt bridge. Internally they are connected by a salt bridge. So this is the cell structure. The cell structure. And here, so like this. So like this here, the Daniel cell also consists of two electrodes. Daniel cell also consists two electrodes. One is zinc electrode. One is zinc electrode and one is zinc electrode. What is zinc electrode? Zinc metal rod dipped in the its solution. So this is the zinc metal rod, and that metal rod is dipped in its solution. So for example, so this is the zinc rod. This is what? Zinc rod, and that is dipped in the its solution. What is its solution? So zinc sulfate, ZnSO4 solution. It is an electrolytic solution. It is an electrolytic solution. This is the one electrode. And second electrode is a copper metal rod, and that is dipped in the copper sulfate solution. That is dipped in the copper sulfate solution like this. Okay, so this is copper sulfate solution, and this is what? Copper rod. Okay, copper metal. Okay, that copper metal is dipped in the copper sulfate solution, and here the zinc metal is dipped in the its solution antunam. Its solution means its sulfate, zinc sulfate solution. Its solution means copper sulfate solution. Okay, so in the zinc sulfate solution, what ions are present? Zinc ions and sulfate ions are present. And in the copper sulfate, copper ions and sulfate ions are present. And so like that, these two metal rods are dipped in its solutions, and these two electrodes are externally connected by a battery like this. Okay, so externally they are connected by a battery like this, and internally they are connected by the salt bridge. Internally they are connected by the salt bridge. So what is the use of salt bridge? So this salt bridge connect the two electrolytic solutions. Two electrolyte solutions. So which maintains the electrical neutrality. So that salt bridge is made up of salts like ammonium chloride. Okay, ammonium chloride, and that salt bridge connect the two electrodes. So yes. So please maintain silence. Last two. Three benches. Last three. Okay, please maintain silence. Then only you can understand. Okay, see here, this is the salt bridge. Okay, this is the salt bridge, and that salt bridge is used to maintain electrical neutrality and also connect the two electrodes internally. Okay, and this is what? Battery. So that battery connect the two electrodes externally. Okay, so this is the construction of the Daniel cell. Okay, this is the construction of the Daniel cell. So in above cell, which is anode and which is cathode? So we have, so the Daniel cell is specific for zinc and copper electrodes. Means Daniell cell consists only zinc and copper electrodes. Okay, so that is specific. The Daniell cell is the Daniell cell composition is the zinc and copper only. Okay, zinc and it consists of only this zinc and copper electrodes. Okay, and in these two electrodes, which is anode and which is cathode. Right. So zinc is the anode and copper is the cathode. How can you say the zinc acts as anode and copper acts as cathode? So you know the structure. Then you easily say that the left side electrode is anode and right side electrode is cathode. So otherwise, if you don't know the structure of the particular cell, how can you say? How can you say? How can you say what metal acts as anode and what metal acts as cathode? So see, we can say what is anode and what is cathode on the basis of their potentials. Their potentials. Every electrode has some potential. Every electrode has some potential. Every metal rod has some potential. Every metal rod has some potential. So based on the potential, we can say the metal, we can say which electrode acts as anode and which electrode acts as cathode. Right. See here the zinc electrode has potential that is 0.76 volts. It is the standard. Okay, everywhere the zinc has 0.76 volts only. This is the standard electrode potential of the zinc. Okay, and next to copper electrode has 0.33 volts. So this is the standard potential of the copper electrode. So in these two, which is having higher potential? Zinc has the higher potential. Zinc has the higher potential. That's why zinc acts as anode. Isn't it? Zinc acts as anode and copper acts as cathode. Copper acts as cathode. For example, so I take copper and iron. So here the iron potential is 0.41 volts. So in these two, which acts as anode and which acts as cathode? In copper and iron acts as anode and copper acts as cathode. Like that. So we can say the electrode which acts as anode and which acts as so right. So in the zinc and copper, zinc acts as anode and copper acts as the cathode. And next point enti? See, so when these two electrodes are connected, automatically the cell reactions are takes place. When the two electrodes are connected internally and externally, automatically or spontaneously, the cell reactions are takes place. So what are the cell reactions? Okay, so the cell reactions are nothing but redox reactions. The cell reactions are nothing but redox reactions. That is the so what happened? The cell reactions are takes place at respect to electrodes. So during the working of electrode, during the working of this cell, what happened? The cell reactions are takes place, means redox reactions are takes place. What reactions? Redox reactions are takes place at respect to electrodes. At respect to electrodes. Okay, right. So what reactions are takes place? Redox reactions. What are redox reactions? Let's see. So at anode. So here this cell has two electrodes, isn't it? One is anode and this is the anode and zinc is the anode and here copper is the cathode. Right? So at anode, what reaction takes place? So here the anode acts as zinc. Zinc acts as anode. And at anode, what reaction takes place? See and remember, always at anode, oxidation reaction takes place. Okay, oxidation reaction takes place at anode. What is oxidation? What is oxidation reaction? Adding up. So in terms of electrons, in terms of electrons, the oxidation can be defined as loss of electrons. Loss of electrons is known as oxidation. Here the zinc metal loses the electrons. Zinc metal loses the electrons during the oxidation reaction. So how many electrons it loses? 2 electrons. 2 electrons are lost by the zinc metal. This is what oxidation reaction. Always oxidation reaction takes place at anode. And next at cathode. At cathode. So see. So during the anodic reaction, what happened? From the anode, here the electrons are liberated. Electrons are liberated, and there an electron path is established. An electron path is established. The electron path or electron flow is nothing but what? Current. Electron flow is nothing but current. And that current or the electrons are moving from left to right side through the battery. Through the battery, that electrons are moving towards this electrode. So ఈ ఎలక్ట్రోడ్ వైపు ఈ ఎలక్ట్రాన్స్ అనేవి మూవ్ అవుతాయి ఈ విధంగా. Okay, so the electrons are moving towards the cathode through the battery, and that electrons are enter into this copper sulfate solution through this copper metal rod. Okay, this copper metal rod, through this copper metal rod, the electrons are enter into the copper sulfate solution. So in the copper sulfate solution, copper ions are present. Copper ions are present. So these copper ions are involved in the cathodic reaction. These copper ions are involved in the cathodic reaction by gain of or by taking the 2 electrons. Okay, so that electrons are gained by the copper ions which are present in the copper sulfate solution. See, by taking electrons, that copper ions get converted into the copper metal. Okay, so this is what cathode reaction. This is what reduction reaction. What is that? Reduction reaction. What is reduction? Gain of electrons. Gain of electrons is known as reduction. Loss of electrons is known as oxidation. Okay, so at anode oxidation and at cathode reduction reactions are takes place. Both the reactions are called redox reaction. Oxidation and reduction reactions are called as redox reactions. Okay, so during cathode reaction, what happened? Here the copper metal is formed, and that copper metal is deposited at the copper rod as a thin layer. As a thin layer, that copper metal is deposited on the surface of this copper metal rod. On the copper surface, on the copper metal, here a thin layer is deposited. That thin layer is, what is the thin layer? Copper metal. So that copper metal is deposited at the copper metal rod. Okay, so these are the anodic reaction and cathodic reaction. And write net reaction. Net reaction of the cell. So for every cell, we have to write anodic reaction and cathodic reaction and net reaction. So remember, so during the working, so you have to write only anodic and cathodic and net reaction. Okay, no need to write any matter. So just write this sentence and write the equations. Anodic equation and anodic reaction and cathodic reaction. Enough, more than enough, right? So write the net reaction. So net reaction means, so add anodic and cathodic reaction. So Zn gives Zn plus 2 electrons, and cathode reaction is copper plus 2 electrons gives rise to copper. So if any common is there, and cancel it. Okay, so 2 electrons and 2 electrons get cancelled, and remaining Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. Zn plus 2 plus Cu. So this is the net reaction of the Daniell cell. So during the working of this Daniell cell, what reaction takes place? Zn plus Cu plus 2 gives rise to Zn plus 2 Cu. So by seeing this equation also, we can say which is anode and which is cathode by seeing only final equation. So what is that? So that is zinc. See, okay. So in the zinc, so you don't know the what is anode and what is cathode. Directly you are seeing the this equation. You don't know this backup. Okay, it tells me. So directly you are seeing this equation, and by seeing this equation, how can you identify what is anode and what is cathode? what is anode and what is cathode. How can you identify? See, so before the reaction, zinc has, what is the oxidation state of zinc? So what is the oxidation state of zinc before the reaction? Before the reaction means, so before the arrow. Before the arrow, that zinc is alone. Zinc is alone. So in alonic element has zero oxidation potential anytime. Anytime, for example, ఒక ఎలిమెంట్ ఇండివిజువల్ గా ఉంది అనుకోండి, సో దట్ హ్యాస్ జీరో పొటెన్షియల్. ఫర్ ఎగ్జాంపుల్ ఆక్సిజన్ ఈస్ దేర్. ఫర్ ఎగ్జాంపుల్ ఆక్సిజన్ ఈస్ దేర్. what is the potential of oxygen? Sir, what is the oxidation state of this oxygen? Zero. So for example, if that oxygen is combining with the water, H2, now, so what is the oxidation state of this oxygen? -2. And here the what is the oxidation state of oxygen? 0. Okay, so అంటే అలోన్ గా ఉన్నప్పుడు ఏ ఎలిమెంట్ కైనా ఏ ఆటమ్ కైనా ఏముంటుంది? జీరో ఆక్సిడేషన్ ఉంటుంది, జీరో ఆక్సిడేషన్ నెంబర్. ఓకే, see here the zinc also has zero oxidation number. So before the reaction, zinc has the zero oxidation number, and after the reaction, zinc has +2 oxidation number. So what about oxidation number? Is it increases or decreases? After the reaction, the zinc oxidation number increases. If oxidation number increases, that involves in the oxidation reaction. That involves in the oxidation reaction. Okay, so where oxidation reaction takes place? Anode. So that zinc used as anode. అర్థమవుతుందా? So here the zinc oxidation number increases. So that what is if oxidation number increases, what is the reaction? Oxidation reaction. So oxidation reaction takes place always at a anode. So that metal or that element acts as anode. So like that we can identify the anode. And similarly, if this is anode, and automatically the next element or next metal acts as cathode. See here, what is the oxidation state of copper here? +2. And after the reaction, that copper oxidation state is 0. And here the oxidation number increases or decreases? Increases. If the oxidation number increases, what is the reaction? What is the reaction? Reduction reaction. If the oxidation number decreases, that is the reduction reaction. Reduction reaction takes place always at a cathode. So that copper is used as cathode. ఇది ఎందుకు చెప్తున్నా అంటే, డ్యూరింగ్ ద సాల్వింగ్ ద ప్రాబ్లమ్స్ డైరెక్ట్లీ గివ్ ద ఈక్వేషన్. సో బై సీయింగ్ ద ఈక్వేషన్ we can identify the anode and cathode. పైకా okay, so right, like this we can identify the anode and cathode by seeing the reaction. Otherwise, how can you identify? By seeing by having the potentials. Otherwise, by seeing the structure. Okay, so by 3 ways we can identify the anode and cathode: by seeing the diagram, and second one by seeing the potentials, and by seeing the equation. By seeing the equations. ఎలా ఇచ్చినా చేయాలి. ఎందుకు చెప్తున్నా అంటే, నెంబర్ ఆఫ్ టైమ్స్ ఎందుకు రిపీట్ చేస్తున్నా అంటే, మీకు ప్రాబ్లమ్స్ ఉన్నాయి, ప్రాబ్లమ్సే ఇస్తారు కాబట్టి సో ప్రాబ్లమ్స్ ఎలా ప్రాబ్లమ్స్లో యానోడ్ని ఎలా ఐడెంటిఫై చేయాలి అండ్ క్యాథోడ్ని ఎలా ఐడెంటిఫై చేయాలి, సో అది తెలియాలి కాబట్టి చెప్తున్నాం. రైట్, సో దిస్ ఈజ్ వాట్ cell reactions. Okay, during cell reactions what happened? The redox reactions are takes place. Okay, so the redox reactions means anodic reaction or cathodic reaction. So here anodic reaction is also known as off reaction. Anodic off reaction antam. Okay, and cathodic reaction is also known as another off reaction. Okay, so anodic and off reaction, cathodic off reaction, combining together we get the net reaction or redox reaction, net reaction. Okay, or cell reaction. So off reaction, after reaction combining together, we get a cell reaction. What is cell reaction? This is the cell reaction. This is the cell reaction. Okay, terms అన్ని ఎందుకు రిపీట్ చేస్తున్నా అంటే ప్రాబ్లమ్స్ లో వస్తాయి. సెల్ రియాక్షన్ మీన్ నథింగ్ బట్ the net reaction of the cell, net reaction of the cell, or okay, redox reaction of the cell. Clear? Okay, and next to see, during the working here, the anode liberate the electrons. Anode liberate the electrons. From that, the current will be generated. That current will be generated from the anode only. Anode దగ్గరనే current అని generate అవుతుంది, and that can be measured in the battery by using galvanometer. So one galvanometer is there. By the galvanometer, how much current will be generated by the cell? Okay, we can calculate the how much current will be generated by the cell. Okay, so here the Daniell cell generated almost to the capacity of this electrode is capacity of this cell is 1.1 volts. So this much of current generated by the Daniell cell. How much current will be generated? 1.1 volt of current generated by the Daniell cell. So generated by the redox reactions. Okay, and this is the capacity. And then finally, so what is the charge of anode and what is the charge of cathode? So what anodic charge and what is the cathodic charge? Anodic charge is, so generally anodic charge is in the electrolysis process, anodic charge is positive and cathodic charge is negative. So in the electrolysis process, but in the electrochemical cells, the charges are reverse. The charges are reverse. So that here the anode carries negative charge and cathode carries positive charge. Okay, so you have to remember the charges of the electrodes in the cell. Okay, in the electrochemical cell. What is the charge of anode here? Negative. Why it is negative? So in the electrochemical cell, anode carries negative charge and cathode carries positive charge. Why? So it is reversed to the electrolysis process. It is reversed to the anode and cathode in the electrolysis process. Okay, so why it is negative? Means during anodic reaction, what happened? The electrons are liberated. What are the electrons? Negatively charged particles. So that on the surface of the anode, the negative charge is established. The negative charge is established. That's why the charge of the anode is negative and the charge of the cathode is positive. So automatically the zinc has the negative charge. Automatically copper also has opposite charge, that is positive charge. Okay, so like that we can give the charges to the respective electrodes. Okay, so this is the cell reaction and this is the working of the cell. And next to cell representation. Okay, so what is cell representation? How can you represent cell? Cell representation. Okay, so here we represented the cell by diagrammatically. So here the cell representation includes the representation of cell by symbolically. Symbolically you have to represent or you have to express the cell. Okay, now how can you represent the cell? See, here the salt bridge is used to separate the two electrodes, isn't it? That salt bridge separated the anode and cathode. So that here the salt bridge can be represented by double vertical line. Okay, the salt bridge can be represented by double vertical line, which is separate the anode and cathode. So kabatti double vertical line manam teeskuntunnam. And left side of the salt bridge, which electrode occupies? Anode, and right side cathode. So that here to the left side of the salt bridge we have to represent the anode and right side cathode. So Mari, how can you represent the anode? And how can you represent the cathode? So what is the anode here? Zinc. And what is the cathode? Copper. And how can you represent the zinc or anode? See, what is the anode? See, here the anode is the zinc metal is dipped in the zinc sulfate solution. Okay, is it miscible with solution? It is a metal rod and that is dipped in the solution. Is it miscible with the solution? Is it miscible or not? No. Why? How can the metal rod and solution is separated? How it is separated? So by its so when I dip this pen in the water, is it miscible with water? No. So we can identify the pen in the water. We can distinguish the pen in the water. How can you distinguish? By its boundary. By its boundary, we can distinguish the pen in the water, right? Otherwise, if you add milk to the water, can you distinguish milk and water? No. So the milk and water both are miscible. There is no boundary for milk and water. There is no boundary for milk and water. So here the pen has a boundary. The pen has a boundary. Similarly, here that metal rod also has a boundary. So that we can identify the metal rod in the zinc sulfate solution. So ఎందుకు చెప్తున్నానంటే see here this boundary separate that metal rod in the solution, so that here that boundary can be represented by a single vertical line. And the single vertical line, left side of the single vertical line represent with the metal. What is the metal? Zinc. And right side of the vertical line represent with the solution in which that metal rod is dipped. Okay, right side of the vertical line represent with the solution. What is the solution? ZnSO4. ZnSO4 solution, and also mention its concentration if it gives the concentration, also mention its concentration in the bracket. Okay, this is what anodic representation. And similarly, what is cathode? So cathode is a copper electrode is a cathode. So how is the copper electrode? Here also it has a boundary. So by the boundary, that copper is distinguished in the copper sulfate solution. So that here use a single vertical line. So during the cathodic representation, left side of the vertical line take the solution, and right side of the vertical line take the metal. Okay, so that is opposite to the anodic representation. Anodic representation lo em తీసుకున్నాం, left side metal తీసుకున్నాం and right side solution తీసుకున్నాం. And during cathodic representation, take the solution left side to the single vertical line and metal right side to the single vertical line. So left side ఏంటి solution ఏంటి ఇక్కడ? Copper sulfate solution, and also mention its concentration. And right side of the vertical line, copper. Okay, so this is the representation of the Daniell cell. So this is the representation of the Daniell cell. So here this is what salt bridge. Identi salt bridge, and that salt bridge separate the what? Anode and cathode. Anode and cathode. Okay, so this is the cell representation of the Daniell cell. Isn't it clear? అర్థమవుతుందా, అర్థమవట్లేదా? Are you understand or not? లాస్ట్ బెంచెస్ కొద్దిగా నాయిస్ చేస్తున్నారు. వినండి, వింటే ఒకసారైనా అర్థమవుతుంది. ఓకే, రైట్. సో దిస్ ఇస్ ద సెల్ రిప్రజెంటేషన్. లైక్ దట్ యూ కెన్ రిప్రజెంట్ ఎనీ సెల్. ఓకే, సో ఎలా రిప్రజెంట్ చేయాలి? సో ద సాల్ట్ బ్రిడ్జ్ denoted by double vertical line. So in some cells there is no salt bridge, but there is a medium. That medium separate the anode and cathode. So in that also you can take double vertical line. So that is what here the double vertical line represent what? A medium which separate the anode and cathode. So like that analyze the that medium or salt bridge. So you can represent with the double vertical line. To the double vertical line, represent anode and right side cathode. Left side anode and right side cathode. So this is the cell representation. And next to EMF of the cell. EMF of the cell. EMF of the cell. So it is also known as E cell. EMF of the cell or E cell. Okay. Cell potential. E means cell. Sir, E means potential. Potential of the cell. EMF means potential of the cell. So we can also represent with the E cell. Okay. Or EMF. What is EMF or E cell? EMF is nothing but cell potential. Every cell electrode has every cell has two electrodes. Every cell has two electrodes. So remember that every cell has two electrodes. Then how can you define EMF or E cell? So EMF or E cell can be defined as the potential difference. The potential difference between two electrodes in a cell. Two electrodes in a cell. Two electrodes in a cell. Okay. The potential difference between two electrodes in a cell is known as EMF or E cell. Okay. Cell consists of two electrodes. Here we have to take the potential difference between the electrodes. Potential difference between the electrodes, that is the potential of the cell or EMF of the cell. And also we can define EMF like this. Or so see the force EMF and electromotive force. Electromotive force. The force which is used to okay, the force which is used to move the electrons from one electrode to another electrode. From one electrode to another electrode. So in a cell, how many electrodes are there? How many electrodes are there? Two electrodes. Okay. The force which is used to move the electrons from one electrode to another electrode is known as EMF. What is EMF? See, in that EMF only we have the definition. The force which is used to move the electrons from one electrode to another electrode is known as EMF. That is electromotive force. Okay. And that electromotive force can be calculated by the taking of potential difference between two electrodes. Potential difference between two electrodes. And here the EMF is also known as E cell. Cell E ante enti ikkada potential of the cell. Potential of the cell means the potential difference between the two electrodes. Cell consists of two electrodes. Okay. The potential difference between the two electrodes is known as E cell or EMF. Right. And next to here we have the formula to calculate the EMF of the cell. Okay. So what is that? So what is the formula? So that potential difference can be calculated by, so E cell is equal to, or EMF is equal to EA plus EC. EA plus EC. This is the formula to calculate the EMF or E cell of the potential, E cell of the electrode, E cell of the what? Cell. Cell potential can be calculated by EA plus EC. What is EA? What is EA? Potential of the anode. Potential of the anode. And what is EC? Potential of the cathode. Potential of the cathode. So by taking the potentials of the anode and cathode, we can calculate the what? Cell potential or E cell ni mana find out cheyochu. Okay. And what is potential of anode? And what is the potential of cathode? What is the potential of anode and what is the potential of cathode? So before going to the electrodic potential, what is the meaning of electrode potential? How many potentials have that particular electrode? So let's see. Okay, let's see the electrode potentials. Okay, enti electrode potential. So ఇంతవరకు ఏం చూసామమ్మా? Cell potential. Cell potential is different from the electrode potential. Okay, so what is electrode potential? See, what is electrode potential? Here electrode potential is denoted by E. Electrode potential is denoted by E. What is electrode potential? So in a Daniell cell, two electrodes are there, isn't it? What are they? One is zinc electrode. What is zinc electrode? Here the zinc metal rod dipped in the zinc sulfate solution. So this is the electrode. This is the one electrode. So this electrode has some potential. This electrode has some potential. That potential is known as electrode potential. Like that, every electrode has some potential. Every electrode has some potential. So how can you define electrode potential? మరి ఎలా డిఫైన్ చేస్తావు? ఎలక్ట్రోడ్ పొటెన్షియల్ అంటే ఏంటి? ఇంతకుముందు ఏం చెప్పుకున్నామమ్మా? సెల్ పొటెన్షియల్ చెప్పుకున్నాం. ఇప్పుడు సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ చెప్పుకుంటున్నాం. సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్. So how can you define this electrode potential? See, here this is the metal rod and that metal rod dipped in its solution. Electrolytic solution lo dip ayi undi. In electrolyte solution, that metal rod is అప్పటి నుంచి అలాగే చెప్తున్నా మేడం, ఏం తగ్గట్లేదు. స్లోగానా? మరి ఎవరు కూడా ఆబ్జెక్షన్ చెప్పట్లేదు. మీరు నోట్స్ రాసుకుంటా అంటే నేను ఆగుతా, వెయిట్ చేస్తా. జస్ట్ వింటున్నారు కావచ్చు అని నేను మూవ్ అవుతున్నా. ఓకేనా? రాసుకుంటే ఆగాలి కదా. ఓకే, రైట్. See, electrode potential is denoted by E. Single electrode potential is denoted by E. And here, what is E? Potential of cell. And here, potential of electrode. Both are E, but ikkada E for electrode, single electrode potential, and cell means potential for two electrodes. That is anodic potential and cathodic potential. Don't confuse. So please, you stand up. What is E and E cell? What is E? Just say the abbreviation of E. What is the meaning of E? Electrode potential, right? Very good. What is E cell? E cell means EMF of what? EMF of E cell. EMF of cell. So right, that is right. So EMF of cell or E cell means the potential of the cell. Potential of the cell is known as EMF. Okay, EMF is also known as E cell, and here E for only that single electrode potential. But how can you define this single electrode potential? Okay, single electrode potential or electrode potential can be defined as the potential difference between see, electrode and electrode. The potential difference between metal rod and the solution. Metal rod and the solution. The potential difference between metal rod and the solution is known as electrode potential. Okay, the potential, what is the meaning of potential? Potential is nothing but energy. What is potential? Potential ante edo anukokandi, energy of the that particular object. Energy of the object. For example, writing ardham kavatledha. Okay, so the potential difference between metal rod and solution is known as electrode potential. Electrode potential. And see, here every this metal and solution has potentials, and here we have to take that potential difference between the metal rod and solution is known as the electrode potential. See, metal rod has some energy, electrolyte solution also has some energy. How can you define, how can you say that metal rod has energy? For example, so this is the I say this is the metal rod. Okay, is this metal rod has energy or not? So this is the pen. It has some energy. How can you say? How can you define the energy of this pen? See, the energy of this pen can be defined as like this: the force which is used to move the pen. That much of force. That force is known as the energy of that pen. ఓకే, ఒకవేళ పెద్ద స్టోన్ ఉంది అనుకోండి, పెద్ద రాయి ఉంది అనుకోండి, సో దాన్ని మూవ్ చేయడానికి కావాల్సిన ఎనర్జీ ఈజ్ నోన్ యాజ్ ద ఎనర్జీ ఆఫ్ దట్ స్టోన్. లైక్ దట్ every metal every metal or every non-living thing or every object has some energy. Okay, and also every solution has some energy. The energy difference between this object and the solution is known as that potential. Okay, the potential difference between the metal rod and solution is known as what? Electrode potential. Okay, and if that potential is measured at if the potential is measured at measured at standard conditions, okay, measured at standard conditions. So if that electrode potential, that is E, measured at standard potentials, okay, standard, if that potential is measured at standard conditions, okay, what are standard conditions? The temperature is 25 degrees centigrade, and in terms of Kelvin you have to add 273, and then it gives 298 Kelvin. And next to pressure is 1 atmospheric pressure, and concentration is 1 molar concentration. How much it is? 1 molar concentration. So these are the standard conditions. If the potential is measured at these conditions, that potential is known as standard potential. Okay, here the standard potential can be denoted by E naught. That standard potential can be denoted by E naught. E naught means standard potential. That potential is measured at standard conditions like temperature 273 Kelvin, so 298 Kelvin, pressure 1 atmosphere, and concentration 1 molar. Okay, is it clear? Right. And next to every electrode has some potential, and that potential may be two types. Every electrode has some potential. Okay, every electrode has some potential. That potential may be two types. Okay, so they are electrode potentials. Electrode potentials are classified into two types. What are they? Oxidation potential and reduction potential. మీరు రాసుకుంటా అంటే ఆగుతాను. రాసుకుంటున్నారా? ఆగండి అంటే ఆగేస్తా. ఫస్ట్ చెప్పాలి, తర్వాత నోట్స్ మళ్ళీ. రైట్, ఈ టాపిక్ అయిపోయిన తర్వాత మళ్ళీ ఫస్ట్ నుంచి చెప్పుకుందాం. ఒక టాపిక్ అయిపోతుంది. ఓకే, రైట్. Every electrode potential, electrode potential classified into two types. What are they? So every electrode has some potential, isn't it? Every electrode has some potential. It may be two types: oxidation potential and reduction potential. And what is oxidation potential? What is oxidation potential? Right. The potential of the electrode at which oxidation reaction takes place. What is oxidation potential? The potential of the electrode at which oxidation reaction takes place is known as oxidation potential. And what is reduction potential? What is reduction potential? The potential of the electrode at which reduction reaction takes place. Means at that electrode reduction reaction takes place. Means at that electrode electrons gained by the ions and get converted into the metal. Okay, see, like that every electrode has two potentials: oxidation potential and reduction potential. What is oxidation potential? What is oxidation potential? Oxidation potential means the potential of the electrode at which oxidation reaction takes place. Okay, oxidation reaction takes place. Okay, and what is reduction potential? Reduction potential, the potential of the electrode at which reduction reaction takes place. Reduction reaction takes place. Okay, is known as reduction potentials. Like that, every electrode has two potentials: oxidation potential and reduction potential. సో ఇది అర్థమైతే మీకు ప్రాబ్లమ్స్ వస్తాయి, లేకపోతే రావు. ఇక్కడే మెయిన్ ప్రాబ్లం అంతా ఇక్కడే. ఓకే, వాట్ ఈజ్ ఈ సెల్? ఈ సెల్ ఇస్ ఈక్వల్ టు ఈఏ ప్లస్ ఈసీ అని చెప్పుకున్నాం. సో every electrode has two potentials: oxidation potentials and reduction potential. Oxidation potential is, this is the oxidation potential and this is the reduction potential. For example, in the Daniell cell at zinc electrode, what reaction takes place? At zinc electrode, what reaction takes place? Oxidation reaction takes place. So that at zinc, which potential is present? Oxidation potential is present. So it has oxidation potential. Okay, and that is 0.76 volts. Okay, how much it is? 0.76 volts. And at the zinc electrode, reduction potential is also present. But the reduction potential is same, but the sign will be changed. Like that, every electrode has two potentials. Okay, ardhamainda? So in a Daniell cell at zinc electrode, what happened? At zinc electrode, oxidation reaction takes place, so that oxidation potential is positive value. And at that electrode, reduction potential is opposite to the oxidation potential. That same quantity, but sign will be changed. Quantity same, but sign will be changed. Okay, ikkada positive aithe ikkada emaindi negative. Okay, so this is what at zinc electrode, the potential that zinc electrode has two potential. And similarly in a Daniell cell at copper electrode, it also has two potentials. Okay, so at copper, what happened? Reduction reaction takes place, so that its potential is known as, what reaction takes place at copper? Reduction reaction takes place, so that its potential is known as reduction potential. Okay, its potential is known as reduction potential, and its value is 0.33 volts. Its value is 0.33 volts. And at that electrode, oxidation potential is also present. Oxidation potential is also there. How much it is? Minus 0.33 volts, isn't it? Okay, minus 0.33 volts. Like that, every electrode has two potentials, oxidation potential and reduction potential. So that depends on the reaction. The reaction takes place at that particular electrode. If the oxidation reaction takes place, that oxidation potential is positive and reduction potential is negative. If reduction reaction takes place, reduction potential is positive and opposite potential, oxidation potential is negative. So like that, we can say what is the potential have at particular electrode. For example, ఇది క్లియరా? అన్ని కలిపి ఒకేసారి రాద్దాం, రైట్? రైట్. సో లైక్ దట్ ఎవ్రీ ఎలక్ట్రోడ్ హ్యాస్ టూ పొటెన్షియల్. ఫర్ ఎగ్జాంపుల్, ఇది అర్థమైతే మీకు అర్థమైనట్టు. ఐరన్ so in this cell, E naught of iron, E naught of iron is 0.41 volts, minus 0.41 volts, and E naught of copper is minus 0.33 volts. ఇప్పుడు నేను అడిగిన వాళ్ళు చెప్పాలి. ఓకే, ఇది అర్థమైతే అందరికీ అర్థమైనట్టే, కాన్సెప్ట్ అర్థమైనట్టే, లేకపోతే లేదు. రైట్, వినండి. సో దిస్ is the cell. This is the cell representation. So in this cell, which is anode and which is cathode? Iron is copper is cathode, right? So here the iron potential is given that minus 0.41 volts. What is the potential? Is it oxidation potential or reduction potential? The given potential is oxidation potential or reduction potential? The given potential is, how can you say minus? Generally at anode, oxidation potential is positive. Oxidation potential is positive. Reduction potential is, the given potential is, so that reduction potential. So that it is a reduction potential. Clear? And next, here copper is the cathode. At cathode, what reduction potential? What is the positive potential at copper? Reduction potential or oxidation potential? Reduction potential is positive and oxidation potential is negative. So that here the negative value is given. So that is it oxidation potential or reduction potential? Oxidation potential. Like that we can identify oxidation potential and reduction potential. Clear? Problem lo ilage istadu. Okay, right. So ikkada elago icham kabatti, so calculate the EMF of this cell. Calculate EMF of this particular cell. Okay, so how can you calculate? What is the formula? What is the formula of this EMF of the cell? EMF of the cell. Okay, so calculate EMF of the following cell. EMF of the following cell. Okay, EMF of the following cell. So then how can you calculate? E cell is equal to, or EMF is equal to, EMF or E cell is equal to, what is the formula? EA plus EC. EA plus EC. Right. What is EA? What is EA? Potential at anode. What is EC? Right. So what is the potential at anode? Generally, what is the potential at anode? Oxidation potential or reduction potential? So generally, at anode, what potential is there? At anode, oxidation reaction takes place so that its potential is oxidation potential. So that oxidation potential at anode plus, so potential of cathode means reduction potential at cathode. Reduction potential at cathode. Okay. So this is the formula. Okay. So e formula and also E cell is equal to, so this is also formula to find the, okay, E cell of the cell or EMF of the cell, right? So substitute these values. Substitute the values. E cell is equal to what is oxidation potential at anode? 0.41. So given potential is reduction potential, but we required oxidation potential. So we take plus 0.41 plus and reduction potential at cathode. Here the cathode is this one, and given potential is oxidation potential, but we need reduction potential at cathode. So how much it is? 0.33 volts, and add these two potentials, we get the 0.74 volts. So this is the cell potential of the this is the cell potential. Okay, ASLU FeSO4 salt bridge CuSO4 Cu. This is the cell, and the cell potential is 0.74 volts. Like that we can do the problem. Okay, so ఈ ప్రాబ్లమ్స్ అలా చేయాలి, రైట్? సో అండ్ ఇవి కాకుండా ఇంకో కాన్సెప్ట్ పైన కూడా ప్రాబ్లమ్స్ ఉంటాయి. సో ఆ కాన్సెప్ట్ చెప్పేసుకొని అన్ని ప్రాబ్లమ్స్ ఒకేసారి చెప్తున్నాం. ఓకేనా? రైట్. సో రాసుకుంటారా? ఎక్కడ డౌట్ ఉంటే అడగండి, చెప్తాను. ఓకే, ఫస్ట్ ఎలక్ట్రోకెమిస్ట్రీ అండ్ అప్లికేషన్స్ చాప్టర్ 1, థర్డ్ చాప్టర్. అండ్ so it deals conversion of chemical energy into electrical energy, and electrical energy into chemical energy. That is the first point. So after that, next the conversion process. Next, after this, the conversion process requires a cell, requires a device. The conversion process requires a device The conversion process requires a device is known as SL. Is known as SL. The conversion process requires a device is known as SL. Okay, next two. The cell can be classified into two types. Cell can be classified into two types: electrochemical cell and electrolytic cell. Electrochemical cell and electrolytic cell. Electrolytic cell. The next two. Electrochemical cell and electrolytic cell. Next, start adding electrochemical cell. Electrochemical cell, and it is a device which converts. It is a device which converts chemical energy into electrical energy. It is a device which converts chemical energy into electrical energy. And next, also known as, and short ka raskondi, short. Also known as galvanic cells or battery. It is also known as galvanic cells or batteries. Next two. Start adding electrolytic cells. Second one, electrolytic cell. Electrolytic cell. Sorry, examples రాసుకోండి. Electrochemical cells ki examples. Electrochemical cells examples. ఎవరు కాన్సెప్ట్ అర్థం కావాలి ఫస్ట్. అలాగే కాదు, ఫస్ట్ ఈ కాన్సెప్ట్ ఎవ్రీ ఎలక్ట్రోడ్ హ్యాస్ టూ పొటెన్షియల్స్. ఫర్ ఎగ్జాంపుల్ జింక్ ఎలక్ట్రోడ్ ఉంది. సో at zinc electrode oxidation reaction takes place, so that oxidation potential is positive. Its opposite potential is negative, right? For example, here iron is a anode. At anode, the potential should be positive. If negative, that is reduction potential. But here at anode we require what? Oxidation potential. So given potential is negative, oxidation potential positive. And alage, so copper idendi copper undi, copper electrode. For example, copper electrode. So at copper electrode, reduction reaction takes place. So that reduction potential is positive and its opposite potential is negative. So in the problem, the given potential is negative. Negative means it is a given potential is oxidation potential, but we need reduction potential. So that plus. వాళ్ళు ఇంకా వేరే దగ్గర వింటున్నారా? మరి క్లియర్గా అర్థమవుతుంది, ఇక్కడ వీళ్ళకే అర్థమవుతుంది. ఓకే, రాసుకున్నారా? రైట్, వెరీ ఓకే. ఇది అర్థమైందా మేడం? కావాలి మళ్ళీ కావాలంటే మళ్ళీ చెప్తాను నేను. ప్రాబ్లమ్స్ వచ్చేటప్పుడు మళ్ళీ చెప్తాను. Right. ఇది అయిపోయింది examples. Next, electrolytic cells. So it is the device which converts electrical energy into chemical energy. Example, electrolysis. After that, side heading, electrochemical cells. Electrochemical cell. It can be explained by taking the example of Daniel cell. Electrochemical cell. Side heading పెట్టుకోండి. It can be explained by taking the example of Daniel cell. It can be explained by the taking of Daniel cell. So again, put the side heading Daniel cell and draw the diagram. Daniel cell and draw the diagram. ఎస్ అల్లరి చేస్తే క్వశ్చన్స్ అడుగుతా. ఎవరు అల్లరి చేస్తే వాళ్ళను క్వశ్చన్స్ అడుగుతా. ఎవరైతే అల్లరి చేస్తారో వాళ్ళని క్వశ్చన్లు అడుగుతా. లేదా డైరెక్ట్ క్లాస్ చెప్పమంటే చెప్పేస్తాను, నోట్స్ అవసరం లేదనుకుంటే. సో కాబట్టి ప్యారలల్గా నేను చెప్పేటప్పుడే ఆగండి సార్ అంటే ఆగుతా. అక్కడ ఇదంతా టైం వేస్ట్. So draw the diagram and then write the working. చెప్తాను నేను అందరికీ. దాని మీద చాలా డౌట్స్, అది క్లియర్గా వింటేనే అర్థమవుతుంది. కొద్దిగా ఫాస్ట్ రాయండి, ఫాస్ట్గా రాసేయండి. So after draw the Daniel cell, write the working and in that anode up to this. కొద్దిగా ఫాస్ట్గా రాయండి, ఫాస్ట్గా రాస్తే త్వరగా కంప్లీట్ చేయాలి. స్లైడ్ అయిపోయిందమ్మా రాయడం? వాయిస్ ఇక్కడికి రావట్లేదు అనుకుంటా. వాయిస్ కరెక్ట్ వినబడితే వాళ్ళు కొంచెం అలర్ట్గా ఉంటారు. ఇక్కడికి వస్తలేదేమో సార్. ఇది జస్ట్ ఆఫ్టర్నూన్ అరేంజ్ చేయండి. So write this final equation in that this is oxidation Zn to Zn plus 2, and here copper plus 2 copper reduction. I draw the arrow, on the arrow write a reduction, and here also draw the arrow and arrow write the reduction oxidation reaction. Okay, finally write capacity, that is 1.1 volts. The capacity of the Daniell cell is 1.1 volts. And next to write the cell representation. Write the cell representation. Cell representation. This is salt bridge, and this is anode, and that is cathode. Okay. Next, write the EMF of the cell. EMF of the cell is also known as E cell, or EMF is equal to the potential difference between difference between two electrodes in a cell, or the force which is used to move the electron from one electrode to another electrode. Move the electrons from one electrode to another electrode. One electrode to another electrode. After that, write this formula. E cell is equal to EA plus EC. దానిలో అయితే బెటర్. ఇప్పుడు ఇది కంప్లీట్ అయితే ఆఫ్టర్నూన్ అక్కడ వస్తుంది. ఇది మైక్ ఉండాలి మేడం, అది లాస్ట్ అది వినవడట్లేదు కాబట్టి వాళ్ళకి కొంచెం నాయిస్ వస్తుంది అక్కడ. So after writing this formula, put the heading, side heading electrode potential. What is this? electrolytic solution. Metal. And right here, the potential difference between metal rod and solution is known as electrode potential. Next to, if potential or E is measured at standard conditions, no, if E is measured at standard conditions like is known as standard potential E naught. Standard potential E naught. Madam, madam, better change their positions. After afternoon, you change the positions, sitting positions. So is known as standard potential, that is E naught. And next to electrode potential. See, you gotta write some point. Every electrode has two potentials. అని ఇది రాసుకోండి. Every electrode has two potentials. And electrode potential, oxidation potential and reduction potential. Oxidation potential, the potential of the electrode at which oxidation reaction takes place. Potential of the electrode at which oxidation reaction takes place. Well, అయిందా మేడం? Okay, close it. వన్కి రావాలా? జనరల్గా ఎప్పుడు అసెంబ్ల్ అవుతారు? 1:30కి రావాలా? మీరు ఎప్పుడు రమ్మంటారు మేడం? సరే కాల్ చేయండి, కాల్ చేస్తే 9866 538 210 3. మేడం మీ పేరు? attitude change. Right. So in a Daniel cell at zinc electrode, oxidation potential. So ikkada Example, in a Daniel cell at a zinc electrode, oxidation potential this much and reduction potential this much. And similarly at copper electrode, reduction potential and oxidation potential. And after that, write this problem.